So what this video is going to go over is more complicated balancing reactions. In the beginning, we start with some very simple reactions, and then we get to a little bit more complex as we get into stoichiometry and our unit having to do with what we're going to use the mole with. So if I take this balanced chemical equation, what you can break this down into is the individual elements. But because these formulas have some polyatomics, like I have an OH and I have an NO3 here, and I have an OH and an NO3 over here, I could really break this down into polyatomics instead of breaking it down to all of the oxygens, all of the hydrogens, all of the nitrogens. That's how I'm going to balance it. And again, this is just another method that you could use. If you find something easier that you do, then do that. Okay, so I'm just going to write each one of the substances left and right and count. So I have one Na, one OH, I have one Fe, and I have three NO3s. Over here I have one Na, I have three OH, I have one Fe, and I have one NO3. So if you balance it according to the polyatomics, you might get there a little faster. For instance, I have three NO3s on the left-hand side, so I'm probably going to need to put a 3 in front of the NaNO3. So I'm going to start there and put a 3 there. That changes my NO3, but it also changes my Na, so you can't just pick what it changes. So that becomes 3 in front of the Na as well. Then I go back over here and go, oh, well, I got 3 OHs here, I only got 1 here. I need 3 in front of that, so I'm going to put a 3 in front of the NaOH. That becomes 3 NAs and 3 OHs. And now I look and see that everything is the same on both sides. So instead of, again, breaking it down per element, you can break it down into polyatomics, as long as you have OH on both sides and NO3 on both sides. So if I look at this next example, I can't do that because the OH has now broken up into this and the water. So I have to balance it more of a normal way or break it down per element. So over here on the left, I have Fe, I have O, and I have H. So I have one Fe, I have 3 O's and 3 H's. And over here, I have 2 Fe, I count up all my O's, and there's a total of 4. And then I have hydrogen, which is 2. So again, in this kind of setup, sometimes you might just have to look at it and say, okay, what am I going to have to do with this? But if you have one substance on the left or the right-hand side of the arrow, that means you're going to have to do something to this. And I would strongly urge you to put a 2 in front of whatever is by itself and see how that helps you or hurts you in the long run. So I have 2 Fe's, so that is going to balance my Fe's very nicely. But my oxygen, again, is going to go up to 6, and my hydrogen is also going to go up to 6. So on this side, I then look at, okay, well, how can I get the hydrogens to 6? So if I put a 3 in front of the waters, that will get hydrogen to 6, and see what it does to the oxygen. So I have 3 oxygens here and 3 oxygens here, so that becomes 6, so it miraculously balances, okay? So whenever you have something by itself, you might just need to put a 2 in front of it. If 2's don't work, try a 3. Please know if a polyatomic is on one side but not on the other, you can't balance it as an OH. You have to break it out into its elements. So the real type of problem that you're going to start to see that is a little more tricky to balance is something called a combustion reaction. Combustion reactions are always going to look the same at this level. You're going to have some kind of carbon molecule burning in oxygen to produce carbon dioxide and water. And this is a very important reaction for all of chemistry, for the world. This is our fossil fuels. We're burning it to get energy. So this is a very important equation. So when I am balancing combustion reactions, you're always going to do it in a particular order. Okay, and there's going to be an easy way for you to remember the order. It's always carbon, then hydrogen, then oxygen. Now, how you're going to remember it is going to be what's over here on the right. So let's look on the left first. I have 5 carbons, I have 12 hydrogens, and 2 oxygens. Over here on the right, I just have 1 carbon. I have a total of 2 hydrogens and 3 oxygens. So if you actually go 1, 2, 3, you will easily remember that oxygen is the last thing to balance. Now, why is oxygen the last thing to balance? That is because O2 is by itself on the reactant side, but it's actually in 2 different compounds on the product side. So if I put something in front of either one of these products, it's going to affect my oxygen. So I want to balance oxygen very, very last because it's going to be the most one that's going to change. So I got to balance my carbon first. So I'm going to put a 5 in front of the CO2. That's going to make carbon 5. And then I could recount my oxygen here or just wait till the end, but I could take 5 times 2 is 10 plus 1 is 11. So I could change that number or just keep it and come back to it. Then my hydrogens, I have 12 on the left. I have 2 on the right. So I'm going to put a 6 in front of that to balance that to 12. Now I need to recount my oxygen. So it's not 11. So if that confuses you, then just count at the end. 5 times 2 is 10. Then I have 6, so that's 16. So oxygen is here by itself. It's a diatomic. So what number times 2 is going to give you 16? Well, that's going to be the 8. So then this is going to be the balancing. I have essentially a 1 in front of the C5H12. We don't write 1s in chemistry. This is an 8, this is a 5, this is a 6. So if I ask for coefficients, it would be 1, 8, 5, 6. Well, they get a little more tricky depending upon the number of carbons you have and how many oxygens you have. So let me show you my method, and there's many different ways of balancing, so don't think my method is the way that you have to do things. I just show it this particular way so that you have something to hold on to when you get a problem like this. Now, you're not going to know that something is amiss until you get into it. So I'm going to put a 4 in front of the CO2. I'm going to count my oxygens last. And then I'm going to put a 5 in front of my waters, and that's going to make everything nice and happy, except for my oxygens. So I have 4 times 2 is 8, plus 5 is 13 oxygens, okay? So odd numbers, okay? Odd numbers are going to be hard to balance because what number am I multiplying by 2 to get to 13? Well, you are taking essentially what I call a fraction. You're taking 13 divided by 2, or 7.5. So I'm going to write 13 divided by 2 just so that you have a visual. So if I have an odd number, you're dividing it by 2. That's 7.5. 7.5 times 2 gives you 13. But we don't like fractions in our balanced chemical equation. So a proper way to finish this is to get rid of that 2. Well, how do you get rid of the 2? Is multiply everything by 2. So if you don't like my method, okay, just whatever the odd number is, you're going to have to put that in front of the oxygen and then multiply everything by 2. Okay. So why don't you try this one? C6H12O plus oxygen goes to CO2 and water. I'm going to pause the video and come back and show you the answer. So I got this far, and then I kind of want to show you my little trick for doing this. So you put a 6 in front of the CO2, a 6 in front of the water, and you get 18 oxygens. You think life is great. I just put a 9 in front of the O2. Well, you don't, because I got an oxygen in this carbon molecule over here. So one way you could do this is to take the amount of oxygen you need minus however many oxygens are in that carbon molecule is 17. So that's really the number I need to put in front of the O2 to get that to the right number of oxygen. So again, if you want to write it as 17 halves so that you remind yourself, oh, I got to multiply everything by 2, or if you just want to write 17 in front of that O2 and then go and multiply everything by 2, whichever way you get to that. So this little trick of subtracting how many oxygens are in that carbon molecule so then you know how many oxygens you're multiplying by to get that O2 is just a way you can kind of focus or a technique you could use when you're doing these combustion style balancing.